Engineering
plus analytics,
equals
product,
product.
the data science version.
Data science version.
All right. Technical difficulties here, pretty common in this field. Maybe I'll let you do it. There we go.
Okay, my name is Ron Dagdag. Good afternoon, everyone. It's second to the last session. We're good. My name is Ron Dagdag. I'm a senior software engineer at Crestron Electronics. I do organize a few meetups here in town, so if you're interested in joining us, I have a link over there, and I'm also a Microsoft MVP.
Hi, I'm Troy Mann. I'm a risk data science Python developer at Toyota Financial Services. Also a Kaggle junkie. I love to do Kaggles. My background is as a cloud architect and data engineer, and also I'm a kind of a meetup junkie. I go to as many meetups as I can here in Dallas. Yeah, so I just want to note that all characters here and entities that we were making that you're going to see are fictitious. There's no resemblance to any real persons, living or dead, blah, blah, blah. It's all coincidental. These are not our actual coworkers.
All right, and all opinions here expressed are solely our own and does not express the views or opinions of our employer.
Okay, so this is our agenda. This is going to be a talk about soft skills in data sciences and in basically big data AI type technologies. We're going to talk about data companies and multidisciplinary teams. We're going to talk about expertise mismatch, engineers versus data scientists, and the definition of done or definition of improvement. But let me just ask real quick by a show of hands, how many here are actually data scientists? Couple. How many are developers? Few, okay. Okay, so Ron, take it away.
All right, I'm going to talk about the stats of normal companies these days. These are news articles that we've seen on internet. Of course, that's true, right? 75% of IoT projects in the US, UK, and India are failing. 85% of AI projects would fail. A lot of these projects everywhere, there's the risk of failures.
All right, so most companies, and this is why we put this on, is me and Ron have known each other for a while, but we got to talking about different data projects that we've been on, different things that we've done, and how sometimes there are a lot of problems with these projects, just from a project management perspective, and also from a soft skills perspective. So a lot of companies, they don't have a strategy for multidisciplinary teams, and what that means are teams of people who work in different departments that they have to work together. So that can be really tough, and that's where we're going to focus here for this talk. But also there's challenges with data diversity, which is bringing together all those different sources of data that's structured and unstructured and everything. Frequently on these projects, especially in startups, you might not have a very good focus. A lot of places, especially in bigger organizations, tend to rely on magic bullets to try to get through AI. And frequently you'll find there's projects that really don't solve a tangible business problem, and those projects are kind of in trouble from the beginning. There's also, from the perspective of user adoption, usually there's not a plan. So what are your users going to do with all of this fancy technology? And finally, especially in the IoT space, privacy and security, those are really big concerns, and often we go into that with no plan at all. So, here we go.
Most AI projects that you work on, most projects you'll be working on different teams, right? Data scientists, operations, developers, subject matter experts, engineers. A lot of these you have to manage across.
Yeah, we all have to work together.
Yeah.
All right, so we're going to do a little skit here about expertise mismatch. Basically, people who walk into these projects and maybe they have no idea what one side looks like from the other side. And, will we engage in a little bit of low tech to kind of help ourselves? You bet. All right. So what we're going to do here, first we're going to show kind of a little skit of a data scientist who, I think we need to go back one, don't we? Well, we'll do this one. There we go. So this one is kind of the, sort of the use case of a junior data scientist, someone who's been a developer. They want to become a junior data scientist, but they may not know the statistics background or the research background to kind of handle some of that. So let's take a look here. What we're going to do is just do a little mock interview. I'm going to be the data scientist doing the interview, and Ron's going to be the developer. So here we go. All right. Can you introduce yourself?
Hi, my name is Ron. My background is a web developer.
Okay, great, great. Normally, we don't interview developers, but you've had some online training that we've seen, and so let's get down to business and ask you just a few simple questions. All right, so first of all, what is a confusion matrix, and how can sensitivity analysis maybe enhance the results you get from that?
I'm kind of confused myself. Is that a 0 or 1 matrix based?
Okay. Well, let's ask another question. So, can you name some ways to validate a time series?
Well, as a developer, I know I can write unit tests, and I know I can validate time itself.
Okay. All right. Well, let's just keep going here. All right. So, what's the difference between bias and variance, and how does that relate to the sizing of a neural network in a business environment? Actually, what's the ideal sample size for a neural network, and maybe how might we generate some better set of samples?
All I heard is like TensorFlow, TensorFlow, TensorFlow. Is that good enough?
Oh, bless your heart. Okay. All right. So our next little skit here is going to be a data scientist that sucks at coding, which I hope it's okay saying sucks. But how many people here have worked with data scientists and seen their code? It's god-awful, isn't it? Okay,
All right,
here, I'm going to be that god-awful data scientist, and Ron's going to interview me this time.
All right. Can you introduce yourself?
Hi, my name is Troy, and I'm a data scientist.
Normally we don't hire people without development experience, but you have a math background. We'll give you a chance. Let's get right to it then. So what is polymorphism, and what is it for, and what's it used?
Polly wants a cracker? Or morphism, is that maybe an Excel or a octave type function?
Not quite. Okay, next question is, what do you call a superclass constructor in Python?
Superclass? Superclass?
That's right, super.
Okay.
Okay, next one.
All
How
right.
about memory leaks? How can memory leaks arise from nested functions?
Oh no, that's not good.
Yeah, that is very important to know. When is it a good idea to use an object-oriented approach, or when is it to use it on a functional approach? And give us some examples.
Well, my code does function. I mean, the probability of it working is 100%, right? So, but object-oriented, I don't really do that very much.
Oh, bless your heart.
All right. Okay, so the take from this is that nobody knows everything. There's a lot of places that want unicorns, but nobody really picks up everything. It takes the whole team to get things done. And, my specialty is putting things into production, and believe me, it takes everybody to get it there. So, we all have to work together. That's the gist of this. Even if we don't know everything, we can get it done if we all pitch in.
All right, let's talk about engineers versus scientists. Since you have a costume, I'm going to wear my costume too here. I'm going to be an engineer today. There you go. That feels better.
And by engineer, we mean developer.
Developer.
Yes, in this context.
A lot of engineers, when you wear doing development and moving things to production, we focus on code, clean code. We focus on testing, deployment, making sure it runs, and being in deployment. In the scientist
Yeah.
world, you know,
Measure, test, learn. So as a data scientist, they're given a problem to solve. They come up with a metric to kind of measure that. They test these things with their notebooks or whatever kind of tool they're using, SAS or anything like that. And then they come up with a learning from that to say that, hey, this is a good model to predict this.
all right. Let's start with the Skit.
Yeah, so this skit, sorry to butt in, but this skit is going to be, we're kind of going to show the contrast between the two. And that's because we work a little differently. Engineers or developers tend to, focus on just writing code and getting things moving, whereas data scientists kind of are focused more on doing experiments.
All right. So let's start. So what does your team need in order to keep this project moving?
Well, just wait for us to finish our code. We're still working on it.
I don't believe you. Last time, you got 10 lines of code that you gave me, and it took you a month to write it.
Well, that really hurts, man. I mean, it took a lot of work to get that 10 lines of code written.
Well, is there anything we can help to test? Write unit tests for it, or something to show progress?
Nope, we're just not ready for that yet.
We need to send something to management. Just some progress report, at least a meeting or anything, right?
Well, if we push this too hard, our metrics are going to be off and it won't pass audit.
So what do we tell our boss then?
Well, you can't predict innovation. It's 99% perspiration and 99% other perspiration. All right.
It's okay. Both engineers and scientists, we both have different ways of doing things, and we have different goals, and we need to respect that.
Yes. It takes the team. All right.
Quick question.
Yes.
What do you expect to fall on your head while writing code?
Oh, well, that's true. I think I got it backwards.
Good.
Okay.
All right. One more thing here.
One last.
All right. This is our last skit. Whoa, this really was our last skit. All right, definition of done. So before, what we looked at was how basically, two different groups can be working on the same thing and maybe the process they use is a little different. Well, also, whether or not they're finished, it can be really different. And these are things that, you definitely run into in the wild. So basically, the scenario for this is that there's a customer complaint. And so, how do we resolve that? So, Ron, take it away.
So how do we go about debugging this model doohickey in our data science cloud?
Well, first of all, it's not a doohickey, it's a godifro. And we usually test it using ETL jobs from the data warehouse.
Well, we've noticed that it's doing a rolling crash since last night. And do you have any ops contact to help us with, trying to figure out, why is the model not running?
It does that every time, all the time. We just have Fred restart it every once in a while.
That's not good, right?
Fred was always able to get it working again. Just as long as the numbers tracking those death row inmates are, secure and correct for their cells, it should be fine.
By the way, where's Fred?
Oh, well, I guess he quit 6 months ago. I forgot about that.
Well, so who is his backup then?
Well, we had this pretty little intern, but I guess she quit too. Uh-oh.
So tell me if I understand this right? We have this code that is in production, and nobody knows how it's built, and no documentation?
Yeah.
And I think it's
For
somewhat
you.
okay.
Yeah. For your information, that scenario really does happen.
It is important for us to learn from our code, because that,
Yeah. Yes, it's important to learn from our mistakes, and there will be many, but we have to kind of work through this. So this is kind of like this conclusion. This comes from Andrew Ng, And he basically, says to be successful, you need to think like a data company. So what that means is the right resources to work on these projects, so people with a good understanding or the ability to develop a good understanding of, statistics, programming, things like that, things that can make our product work. The other thing from our second skit was, there needs to be a good understanding of AI to be able to execute on these things. So part of that is project management, which is sadly in the AI space, there's not really good ways to solve that. You have developers who tend to use Agile, and then data scientists who tend to use forms of Kanban. So working through that, and especially having like a really, really good project manager that can understand both is pretty essential. And then also just the strategic direction. So basically knowing everybody knowing what's going on, what to do, and being able to kind of pull through to the finish line. So this is, we made this, for people who may be potential junior data scientists kind of interested in the field, to know that when you walk into these, sometimes these projects may be a little hairy, but if you go in, show interest, and really work hard at it, you can be successful. And we hope that maybe some project manager out there sees this and they gain a little bit of understanding of what's going to go. That's it. We're done. We're open for any questions if you have them.
Thank you very much.
Appreciate it.
Yeah, thank you. Any questions? Does this sound familiar?
Go ahead, it's quite fascinating. The skits were fun. Here's what I find, just having a program manager background, working with data scientists and technology folks, and subject matter, that when we embark on some of these solutions, the current process doesn't take the lend themselves very well to the experimental nature that typically
the current process, this project management process in particular, don't lend themselves well to the experimental nature of product innovation and introducing new machine learning data and data solutions around that. So I mean, I'm just real curious to hear, just from your experience in your organizations, kind of what approaches are you guys taking to really tackle that. I think you did a great job of recognizing the problem, and it kind of identified with my experience from the aspect that, hey, we do need more project management process that lend themselves to, again, that experimental nature that may occur, because the traditional model is pretty kind of fixed, if you will, and really change is very dynamic. You got Agile, but Agile sometimes doesn't fit very well with the data science process or machine learning methodology as well. So
Mind if I
what do you, yeah.
take this? Yeah. First of all, let me just say amen. So that's the problem. So, part of the thing is that, different groups work together, and especially for data science groups, it's hard for them to show progress because they're doing experiments, right? And so, it's like, how do you measure that? And so there's a couple of things out there. Really, it's like Andrew Ng says, there's not really a great solution to this problem, but there's a couple of things out there. Microsoft has a process called TDSP that is kind of, okay, it's a good start. Maybe a good start to at least identify, hey, here's a business process, here's deployment that's separate from, data discovery and separate from model building. So it kind of helps sometimes to classify those. And then also, what I've noticed just with a lot of data scientists, I'm more of a data engineer myself, but most data scientists tend to work in Kanban type fashion. So they'll have boards or something, usually with sticky notes or something like that. That works pretty well for them because they can document what experiment they're working on and show some progress. Problem is a lot of project managers, they'll be working in Excel or something like that and not be able to bring, you know, the Kanban style into Excel. And so that's kind of been a big problem. If you can kind of work to bring that over, you know, into Excel or Planner or even Trello, you know, whatever it takes on that. But basically, you know, even if you go in and take, you know, an Agile board and just show it as the task, gosh, I'm forgetting. Yeah, just as columns rather than, you know, a whole bunch of stories, wherever you can see it, you know, to do, in progress, done. Yeah, yeah, those swim lanes, right, those swim lanes tend to work really, really well. Whoa, if you can if you can get a project manager trained who can understand those.
And just to add just a follow-up to that, I think the other aspect of it too that I think quite often when we talk about the experimental nature of machine learning and AI is as you go through that learning cycle, how do you go back to a business executive and quantify that, hey, we actually made progress through our failures. You know what I'm saying? And so that's some of that, you know, and put a very aggressive and say, you know, you get the project manager, he has deliverables, you want to show deliverables in your progress, but sometimes it'll be simply just learning, right? And then what's the, how do you quantify that value back to the business? Like, we actually have made progress through our failures.
Sure. Well, in a way that's sort of like writing code. I mean, code progresses through the failures, the bugs in the code that you make, and you correct those bugs and keep moving. So for the data team, you know, if you can go and kind of communicate with them a little bit better, maybe say, we're working on, you know, a model that's linear regression. We're going to try that today. And, you know, if you get their language down, then it becomes easier to be able to document this. So, and to show actual progress. Because you can, you know, too often what we do is we expect like a lot of stuff from data scientists that, you know, they'll just magically produce this product. If you can break it down and say, hey, here's a regression model with data set A. Here's a regression model with data set B, data set C. So this is what we're going to work on this week. Just like doing Scrum or whatever, you know, you can break these down, but there's a big language barrier because, you know, most people who are managers have no idea, you know, what the language is. And so that's part of it as well. If you can communicate, just like, you know, it doesn't make any more sense to a manager than, you know, code that somebody's writing. They don't know Java from JavaScript. But if you kind of put the language down right and break this up into tasks and can show it on a board some way, that can communicate to management and to data scientists and even to developers, you know, kind of the whole thing. And it does help sometimes everybody get in a room. One of the hardest but best projects I've ever been on, there was 12 of us that went into a room and we made a huge IoT proposal with all kinds of really advanced streaming and stuff like that. And so just all of us getting together, we all put it and we won that proposal. So, you know, a lot of it's just getting the language down and just getting together more often. Too often engineering and analytics are siloed. The more you work together, the better it gets.
All right, with that said, thanks again.
Thank you.
Thank you. Really good question.